Welcome to this P4 walkthrough of the June 2023 paper. Right, let's get started. Okay, so we got a binomial expansion here. The first thing we want to do is we want to have this as 1 minus or 1 plus, So we want to take out this quarter. So taking a quarter out, we've got a quarter to the power 3 over 2. And that's going to be 1 minus. Now, if I'm taking a quarter out of a half, then that's going to leave it as 2, isn't it? Timesing it by 4. So 2x to the minus 3 over 2. So now if I times a quarter by the minus 2, it gives me minus a half. Okay, so that's what I am doing now. A quarter to the power minus 3 over 2 is 8. So we've got 8, 1 minus 2x to the minus 3 over 2. So next I'm going to focus on this bit, and then I'll multiply through by 8 at the end. So I'm going to do 1 minus 2x to the minus 3 over 2. Plus, now it's minus 3 over 2 n, times by my x term, which is 2x. And I gotta go as far as our first 4 terms. So that's the first 2 terms. Plus, now it's n minus 1. So minus 3 over 2 minus 1 is minus 5 over 2 minus 2x squared. Plus, I'm just running out of room. I'll just make a little bit of room quickly. There we are. Now that's over 2 factorial, or just 2 in this case. And then I've got minus 3 over 2 minus 5 over 2 minus 7 over 2 minus 2x cubed over 3 factorial. And then it's just going to carry on from there. So we've got 1 plus 3x plus 15 over 2x squared plus 3 times 5 times 7, 105 over 6, so 35 over 2x cubed. Now what I need to do is multiply by the 8, isn't it? So because I've said that this is what I'm doing, I need to, before multiplying by the 8, put the original back up here. So this is 1 quarter minus 1 half x minus 3 over 2, and this is going to be equal to 8 multiplied by that expansion above. Okay, so that's 8 plus 24x plus 60x squared plus 140x cubed. Okay, and that's all there is to the expansion. So first 5 marks, relatively straightforward. Now part B, the inside of both these brackets are the same, and the inside of this bracket is the same. So this is just like going, I've got a to the power n times a to the power minus 3 over 2 equals a to the power a half. So it's quite simply this plus this equals a half. N plus or minus 3 over 2 equals a half. So add the 3 over 2 to the other side, and n equals 2. So part B is just simply n equals 2. Okay. Hence or otherwise, find the first 3 terms of the binomial expansion in ascending powers of. So part C, we need to find what a quarter minus half x to the power of half is. So it's a quarter minus a half x squared times a quarter minus a half x to the minus 3 over 2. So expanding this one, the squared terms, is going to be a quarter squared, so that's 1/16th, times double the product, so a quarter times a half, or minus a half, is minus 1/8, double minus a quarter, x, and then square the last term, plus 1/4 x squared. And then that's going to be multiplied by 8, 24x, 60x squared, 140x cubed, and so on. So first we multiply the 1/16th by everything, and that gives you 8 over 16 plus 24x over 16 plus 60x squared over 16. And since I need to find the first 3 terms, I'm only going to go as far as x squared. So the x cubed term here is not needed. Plus, now I'm going to multiply the minus a quarter x by everything. So minus a quarter x by 8 minus a quarter x by 24x, and then minus a quarter x times the 60x squared will give me an x cubed term, which is the 4th term in the sequence, so that I don't need. So plus, and then finally I'm going to be multiplying by the quarter x squared, so quarter x squared multiplied by 8, and a quarter x squared multiplied by 24x will give me an x cubed term, which again then is the 4th term in the sequence, so I don't need that. So 8 over 16 is a half. Okay, 24 over 16 is 3 over 2, so it's 3 over 2x. I'm just taking an extra step here, you could just jump straight to the answer. Okay, 15 over 4x squared. Then I've got minus a quarter times 8, so minus 2x. Minus a quarter times 24 is minus 6x squared, and then 8 over 4 is 2 plus 2x squared. So now I've got a half, that's my only what's called term. Then I've got 3 over 2 minus 2, so it's going to be minus a half x. And then I've got 15 over 4 minus 6 plus 2x squared, that's minus 1/4 x squared, plus, and so on. Okay, and then that's all there is to part 3. Okay, so first question, not too bad, awkward numbers, dealing with the fractions, fractional power, fractional values in it, but overall not, quite straightforward. Okay, question 2. We've got a curve here, it's given here, Not particularly nice equation, but you know, not too bad. Find the point P lies on C, find the y coordinates of P. So it has an x coordinate of 2. So for P, we just need to substitute 2 in for x. So it's 2 squared minus 4 times 2 times y plus y squared equals 13. So we've got 4 minus 8y plus y squared equals 13. Y squared minus 8y plus 4 minus 13 equals 0, or y squared minus 8y minus 9 equals 0. This will factorize to 1 and 9. That's a minus, and that is a plus. So y equals -1 or y equals 9. We clearly want a positive value for y, therefore y equals 9 is our only solution. Now part B is differentiate. So implicit differentiation here, you're going to differentiate each term. So 2x differentiates to 2x ln 2 minus 4xy. Now that's a product rule. So it's going to be, I'm just going to turn this into a plus, and I'm just going to put this in brackets. Okay, so you've got minus 4 and y. Sorry, minus 4x and y. du by dx is minus 4, and dv by dy is dy by dx. Okay, and then we've got these two plus these two. So minus 4x dy by dx plus minus 4y. Okay, that's what I've got. And then y squared is 2y dy by dx, and 13 is 0. At 13 at the end there being 0, it's obvious, but in exam conditions I've seen it loads of times where students leave it as 13. They forget that they've differentiated it and it's 0. They've been concentrated on the other differentiations so much that they miss a simple value at the end. Okay, that's all there is to it, but we can simplify it a little bit. Because we have to find dy by dx, we really need to get the dy by dx's on their own. So 2y dy by dx minus 4x dy by dx. So those two I'm going to keep staying on the left, and then on the right we've got 4y minus 2x ln 2. Okay, this could be the other way around, because you could have this the other way around. We've taken them to the right, so positive 4x and a negative 2y, and then these would be the other way around, a negative 4y and a positive 2 to the power x ln 2. And now factorising out the dy by dx, we get 2y minus 4x, so that's going to be on the bottom. So 4y minus 2x, 2 to the power x ln 2 over 2y minus 4x. And again, you know, the signs could be switched if you did it the other way around. Now the tangent to P, or tangent to C at P, so there's a tangent here at P, something like that, that's going to cross a point Q. Find the coordinates of Q, give your answer in that form. So first let's find the gradient of the tangent. We've got the coordinates 2, 9, so dy by dx equals 4 times 9 minus 2 to the power 2 ln 2 over 2 times 9 minus 4 times 2. So that's 36 minus 4 ln 2 over 18 minus 8. And I could divide through by 2. Well, I couldn't really simplify any further. Okay, then I need to put it into y minus y1 equals mx minus x1 to find the equation. So y minus 9 equals 18 minus 2 ln 2 over 5 times x minus 2. Now at this point I don't need to simplify this because I've got to find the x coordinate of Q, and this hits the x-axis. So y equals 0. So I can substitute y equals 0 in straight away. And we get minus 9, 18 minus 2 ln 2 over 5 equals x minus, and next times by x minus 2. Okay, so that's what I've got to do. Now dividing by this will give me minus 45 over 18 minus 2 ln 2 equals x minus 2, and taking the 2 across gives me 2, like a positive 2, plus minus 45 over 18 minus 2 ln 2. Now obviously that's not the form that we wanted in, so this I need to turn into the same bottom value as that, so it's just 2 times. I'll just make a little bit of room. So my x equals 36 minus 4 ln 2 over 18 minus 2 ln 2. That's what I've replaced the 2 by. Yeah, because 2 times this bottom value over this bottom value, well, it would cancel out and leave you 2. Yeah, and this is then minus 45 over 18 minus 2 ln 2. So 36 minus 45 is minus 9 minus 4 ln 2 over 18 minus 2 ln 2. And there we have it. This is the same as 4 ln 2 plus 9 over 2 ln 2 minus 18. And that was the form, wasn't it, that they wanted it in the ln2s in the beginning. Okay, so times in top and bottom by minus 1 keeps it the same, but there you have it. So A, B, C and D. Job done. Again, a bit of an awkward one, awkward numbers. Skills not too difficult in skills there, but again a bit time consuming. It was with 10 marks in total though. Again, you know, straightforward, just some awkward values. So part A, question 3 now. Part A, express in partial fractions. So 8x minus 5 over 2x minus 1 and 4x minus 3. So that's a over 2x minus 1 plus b over 4x minus 3. Apologise for my handwriting today. I don't know what's going on. Okay, so we've got 8x minus 5 is equivalent to a times 4x minus 3 plus b times 2x minus 1. So a couple of values to substitute in. So first of all, let x equal 3 over 4, as that will make this first bracket disappear. So 8 times 3 over 4 minus 5 equals 0 plus b. Now, of course, you don't have to substitute in values to make the brackets equal go to 0. You could just substitute 0 in, and then you could substitute 1 in, two simultaneous equations, and solve for a and b that way. Okay. So this is equal to half b on that side, 2 times 6, 2 times 2 6, that's 1. So b equals 2. And then let x equal half, and that will get rid of the second bracket then. So 8 times a half minus 5 is equal to a 4 times a half minus 3 plus 0. So 4 times a half is 2, 2 minus 3 is minus 1, so minus a. 8 times a half is 4, 4 minus 5 is minus 1, so a equals 1. Okay, so therefore my f of x is equivalent to 1 over 2x minus 1 plus 2 over 4x minus 3. And you should always state this at the end, f of x, or the whole thing if it doesn't have an f of x there, but you need to make sure you state that at the end. Now part B, we are integrating f of x dx. So we are integrating 1 over 2x minus 1 plus 2 over 4x minus 3 dx. So these are going to be logs now. So it's a log 2x minus 1, and then divide by the inside differentiated. So inside differentiated is 2, so we divide by 2 and we get a half. And then it's log 4x minus 3, divide by the inside differentiated. Inside differentiates 4, so it's divide by 4 quarter, but then it was times by 2, so this is actually not a quarter, it's 2 quarters, or a half in that case. And plus c, don't forget the plus c as you risk losing a mark, so we got a half ln 2x minus 1 plus a half L, I don't know what I'm doing here, ln 4x minus 3 plus c. Now, before we get started, this here, we've got two logs and they both half times. So taking that half out, I've got ln, and then it's 2x minus 1 times by 4x minus 3 plus c. Okay, because we're adding the two, same as multiplying. Now, let's move on to the actual question. So we're going to substitute 3k and k into f of x dx, and that is equal to a half ln 20. So that is a half ln 2x minus 1 times by 4x minus 3 between 3k and k, and equals a half ln 20. So, I mean, I could get rid of the halves on both sides at the moment, but I'll leave it for the time being. But we got a half ln, and then we've got 6k minus 1 times by 12k minus 3 minus a half ln, and it's 2k minus 1 times by 4k minus 3, and that equals to a half ln 20. Now these are taken away, so half ln, we've got 6k minus 1, 12k minus 3 over 2k minus 1, 4k minus 3 equals a half ln 20. So now quite clearly this part is equal to 20. So just carrying on up here, 6k minus 1 times 12k minus 3 over 2k minus 1 times 4k minus 3 is equal to 20. So 6k minus 1, 12k minus 3 equals 20 times 2k minus 1, 4k minus 3. So expanding these, 72k squared minus 18 minus 12 minus 30k, and minus 3 times minus 1 is plus 3, and then we've got 20 lots of 8k squared minus 6k minus 4k is minus 10k, and then again it's 3. So 72k squared minus 30k plus 3 equals 160k squared minus 200k plus 60. So taking everything to the right, 160 minus 72 is 88k squared, minus 200 plus 30 is minus 170k, and 60 minus 3 is 57. Okay, then using the formula, I get two answers to k, 3 over 2 and 19 over 44. But in the question it says that x is greater than 1. Therefore that's not an answer, so k equals 3 over 2. Obviously I just used my calculator there, but you should, use the formula, use your calculator anyway to check and get your answer, but write down the formula and then go from there. Okay, and that's question 3 done. So question 4, we've got to find an equation. So you think about it, the origin to A to B are these two vectors because they're position vectors, and then AB that way. Okay, so AB is B minus A, and then it's from position vector A. You can do it from position vector B, it's up to you. Okay, so what we're looking at here is R equals, now I'm going to do this in vector form, 48k plus lambda times, and then it's the difference between the two, like B minus A, so 5 minus 4, 6 minus 8, 3 minus 1. So it's 4, 8, 1 plus lambda 1 minus 2, 2. Okay? Or R equals 4i plus 8j plus k plus lambda I minus 2j plus 2k. Okay, either way of writing it. And that's position vector L. Right, part B. The point C lies on L so that PC is perpendicular to L. So let's find PC. Okay, PC is, so C is a general point on L. So PC is C minus P. So C, a general point would be 4 plus lambda 8 minus 2 lambda 1 plus 2 lambda. So it's just from L from here, isn't it? General point minus P, and what's P? 2 minus 2, 1. So 4 minus 2 says 2 plus lambda 10 minus 2 lambda and 2 lambda. Now, since it says it's perpendicular, then PC times by the direction, so 1 minus 2, 2 of L should equal 0. So that means, where are we? 2 plus lambda plus, minus 2 times 10 minus 2 lambda plus 2 times 2 lambda equals 0. So 2 plus lambda minus 20 plus 4 lambda plus 4 lambda. Okay then, 4 lambda equals 0. We'll just carry on up here. 4, 4 and 1 says 9. Okay, 9 lambda minus 18 equals 0. 9 lambda equals 18. Lambda equals 2. Now substituting that into L, so for C, we've got then, where are we? 4, 8, 1 plus 2 times 1 minus 2, 2. So that is 4 plus 2, so 6. 8 minus 4 is 4, and 1 plus 4 is 5. So that's what we got, or 6i plus 4j plus 5k. k. Oh, the coordinates would be 6, 4, 5. Okay, and that's it for part B. Now the point P dash is the reflection of P in the line L. Find the coordinates of P dash. Okay, now for this one, imagine this is L. We got a point C on it, and somewhere down here is P. And that's perpendicular, that's P. Then its reflection is going to be up here, like so. So it's going to be P and then 2 PC to get to P with a dash. Okay, so it's along this line, the PC line, but it's times by 2. Okay, so the vector PC times by, so we go from P to C to P dash. So it's going to be P plus 2PC. Okay, so just rub that out. So to find P dash is going to be P plus 2PC. And P is 2 minus 2, 1 plus 2 lots of, and PC, and this is 4, 6, 4. So it's just, you know, lambda's 2, so 4, 6, 4. And then I've just got to add these up. So 2 plus 8 is 10, minus 2 plus 12 is 10, and 1 plus 8 is 9. So that's it for P dash, or this will be 10, 10, 9, or 10i plus 10j plus 9k. However you want to write it. Actually, it says coordinates, so leave it like 10, 10, and 9. So PP, the distance PP, is the same as twice the distance PC, which is 2 times 4 squared plus 6 squared plus 4 squared. Equals 4 root 17. Okay, so part 1, integrating x squared e of x dx. So you're basically going to call that one u and that one dv by dx. Yeah. So it's going to be u v, is x squared, and e to the x integrated is just e to the x, minus du by dx, which is 2x times by v, ex dx. Now on the second set, we're going to call this u and this one dv by dx again. And then it's going to be uv, so 2x e to the x minus, and then it's v times by du by dx, so 2e to the x dx. So this is now x squared e to the x minus 2x e to the x minus 2e to the x plus c. Oh, sorry, this is a plus, isn't it? Because it's minus and minus. And then that's it. Part 1 is done. Okay, second one we're using substitution. So this is u equals 1 minus 3x to the half. Du by dx is equal to a half 1 minus 3x times by minus 3. So minus 3 over 2. Oh, sorry, that's going to be to the minus a half. 1 minus 3x to the minus a half, like so. So that means that du equals 3 over 2 times, well, 1 minus 3x to the half on the bottom dx. So that's a lot like what we've got here, isn't it? Now, from the u, from this, we got u squared equals 1 minus 3x. 3x equals 1 minus u squared. X equals 1 minus u squared over 3. So these now we can substitute in. Now I'm going to call this I. So then I can use I down here. So, and from here, if I take the 2 and the 3 across, I could keep the 3 in there. I'll just take the 2 du equals 3 over root 1 minus 3x dx. Because then in this part, yeah, I'm taking 9 out, and that leaves me with 3. I take 9x out, 3 over root 1 minus 3x dx, yeah, which is what I've got here. So my I equals 9x times by 2 du. So that's 18x. And 18x, x is 1 minus u squared over 3 du. The 3's will cancel, leaving me with 6 there. So we're integrating 6 minus 6 u squared du. Sorry, I have made a mistake. There's a minus here. So that had a minus in it. And that had a minus in it. So when it's substituted in, it had a minus, a minus, a minus in it. So it's 6u squared minus 6 du. Or I could take the 6 outside. So always just double check there. Going from here to here, I dropped the minus sign. So just put it back in. Right. Just block that off. So carrying on here, integrating 6u cubed over 3 minus 6u plus c, 2u cubed minus 6u plus c. Now we're going to substitute u back in, so we get 2u cubed, so u is 1 minus 3x to the power a half, so it's 3 over 2, minus 6, 1 minus 3x to the power a half plus c. And now looking at this, this is being factorized out, so we've got to factorize this. So I can take 1 minus 3x to the power of half out of both of these. And I can also take 2 out, but since we've got a minus 2 outside here, I'll take a minus 2 out. So minus 2, 1 minus 3x to the power of half. Now if I've taken minus 2 out of this, there's going to be a minus 1. And if I've taken this to the half out, is this, just this, sorry, to the power 1. So 1 minus 3x, and then plus 3, because I've just taken the minus 2 of that and that out, so it's just left with 3. Plus k minus 2, 1 minus 3x to the half, brackets, and we got minus 1 plus 3 is 2, and we've got minus times minus, so we've got 3x plus 2 inside plus k, and that is a and b to be found, yeah, and k is a constant. Sorry for me just about squeezing it in, I should have made more room early on in the question. So question 6, we got a differential equation here, and it's given us a couple of key values here and here. So that will be able to find our constant with. So if I rearrange this, I've got 1 over theta minus 15 squared d theta. And then on the right, I got minus k d t. So I'll integrate the right first, so it's minus k t. And integrating the left, we've got theta minus 15. I went to the minus 2, add 1 to the power, minus 1, divide by the power. So that's what we've got here, plus c. So we just got, obviously just have one constant there. Now, the temperature of the car is 85 degrees the instant it's turned off. So 85 degrees when t equals 0, 40 degrees when t equals 10. So those are the values I've got. I've got 2 unknowns and then 2 sets of values. So let me rewrite this equation as minus 1 over theta minus 15 equals minus k t plus c. So substituting theta equals 85, t equals 0 in, we get minus 1 over 85 minus 15 is 70 equals c. So that gives me my c straight away. And then we're going to substitute in 40 and 10. So minus 1 over 40 minus 15 is 25 equals minus 10k minus 1 over 70, as we've already found out what c is. And then rearranging this, we get k is 9 over 3,500. So just adding the 170 on and divide by negative 10 there. So I've got my k and I've got my c now. So my equation is minus 1 over theta minus 15 equals minus 9 over 3,500 t minus 1 over 70. and we've got to get it into this form. Theta equals, they're all minuses, so taking the ones from the left to the right and the ones from the right to the left, I can end up with this. Now on the right we've got 9t over 3,500. Now times 70 by 50 will give me 3,500, so plus 50. And then that means that theta minus 15 is equal to 3,500 over 9t plus 50. And then of course add the 15 on, so we get theta equals 15 plus 3,500 over 9t plus 50. Now we need to make it one fraction. Give me a second. There we are, that's better. So it's 15 times 9t plus 50 over 9t plus 50 plus 3,500 over 9t plus 50. That's what we got. So 15 times 9 gives me 135t. 15 times 50 is 750 plus 3,500 is 4250, and that's over 9t plus 50. So that is my theta then. Now part B is for the temperature to reach 20 degrees. So it's just substituting 20 into here and finding T. So that's 180T plus 1000 equals 135T plus 4250. So 180 minus 135 is 45T. Take away the 1000 is 3,250. 3,250 divided by 45. T equals 650 over 9, which is 72.2 occurring minutes. So I'll give you answer to the nearest minute, so 72 minutes. It's actually 72 minutes 13 seconds there. Okay, job done. That was an easy question. Okay, this is a nice bit, makes this a lot easier. So prove that by contradiction that root 7 is irrational. So assume, sorry, my pen was wrong then. Assume root 7 is rational. Therefore, or so, root 7 is equal to A over B. Okay, where A and B have no common factors. Where A and B have no common factors. Therefore 7 equals A squared over B squared. So 7B squared is equal to A squared. So A squared is a multiple of 7. Therefore A is a multiple of 7. which is what it tells us we can assume in the question. So now we can replace a squared with 7k, or let a equal 7k. So this is now 7b squared equals 49k squared. B squared equals 7k squared. So b squared is a multiple of 7. Therefore, b is a multiple of 7. So now we've shown that both a and b are multiples of 7. Okay, so as a and b are both multiples of 7. Sorry, trying to concentrate on writing and speaking at the same time, so sometimes I have to stop, and spelling. Okay, so this contradicts the fact that a and b have no common factors. Okay, hence root 7 must be rational. And that's it. Okay, and it's the same for all of the kind of roots proved by contradiction. Just, you know, learn this one as well. You know, it might not come up next time, but you'll learn it. It'll be the same for root 3, root 2, root 5, whatever. Okay. Okay, final question. Parametric equations. Nice. So find the x coordinate of q. So q there, the y coordinate is 0. So 0 equals t minus 1 over t. Yeah. So t equals 1 over t. T squared. T equals 1. And substituting that into the x. So x equals 1 plus 1 over 1, which is 2. So x equals 2 is your first coordinate. Right, part B. We've got the line L as normal to C at the point P, given that t equals 2 at P, right in the coordinates of P. So that's just when t equals 2. So y equals 2 minus a half. So that's 3 over 2. Sorry, just rewrite that. 3 over 2. And x equals t plus a half. So that's 5 over 2. So point P is 3 over 2, 5 over 2. Oh, sorry. The x is 5 over 2. And the y is 3 over 2. I did the y first there. Okay, C is use calculus to show that the equation of L is right. So we want to find dy by dx. So first let's find dx by dt. Now this is t plus t to the minus 1. So it's going to be 1. Now bring it down, minus 1. Take away 1, so it's 1 over t squared. dy by dt is the same but it's plus. So dy by dx is dy by dt times dt by dx. So it's 1 plus 1 over t squared over 1 minus 1 over t squared. And there's no need to simplify this. We know that t equals 2 at p. So dy by dx is 1 plus a quarter over 1 minus a quarter. So 1 plus a quarter over 1 minus a quarter is 5 over 3. Now that's the equation of the tangent. So for normal, m is minus 3 over 5. Okay, so we got point P, we've got the normal, then now we can find the equation. So y minus y1 equals mx minus x1. So y minus 3 over 2 equals minus 3 fifths x minus 5 over 2. So multiply through by 5 first and then expand the brackets. So we've got 5y minus 15 over 2 equals minus 3x plus 15 over 2. Taking everything to the left as the x is negative, we get 3x plus 5y, and taking the minus 15 over 2 to the other side will give me 15. 15 over 2 plus 15 over 2 is 15. And that was what was required. Now, part D. So the region R, shown shaded, is bounded by the line L, the x-axis and the curve C. Using algebraic integration, find the exact volume of the solid of revolution formed when R is rotated 2 pi. Okay. Okay, so volume equals pi times y squared dx. So in this case, it's going to be y squared dx by dt dt. Because dt's would like kind of cancel, leaving the dx in there. Okay, so that's the first step. So y squared is, there's pi first. Y squared is t minus 1 over t all squared. dx by dt, we had done that. That was 1 plus, no, 1 minus, wasn't it? 1 over t squared dt. So t squared minus times this minus 1 minus 2 plus 1 over t squared minus 1 over t squared dt. And then expanding the brackets, we've got t squared, so times in t squared by both of them first. So t squared minus 1. Now times in minus 2 by both, so minus 2 over t squared. Sorry, plus, because there's 2 minuses there. And then plus 1 over t squared minus 1 over t to the 4 dt. So that equals t squared minus 3 plus 3 over t squared minus 1 over t to the 4 dt. Now, before we go any further, I just realised I've jumped straight into this and I haven't explained what I'm doing. So what I'm doing is, if I do this in red, it's from P down. Okay, so what I'm doing here is I'm integrating the curve. So the area under the curve between P and Q. Now, T at P is 1. So I should have written at P T equals 1 and at Q P equals 1 at P T equals 2. So I'm going to integrate this between 2 and 1. But that's only going to give me this area here. And then the second part of the area I'll do as a triangle. So I'll do that once I've done the integration, okay? Now back to the integration. So I've got pi so it's t cubed over 3 minus 3t plus minus 3 over t plus 1 over 3t cubed. So taking the pi outside, we've got 2 cubed is 8 over 3 minus 6 minus 3 over 2 plus 2 cubed is 8 times 1 over 24 minus 1 over 3 minus 3 minus 3 plus 1 over 3. And all that comes to 13 over 24 pi. Okay, now let's work out the triangle. So the triangle is between 2 and 5 on the x and 3 over 2 on the y. Now, because it's being rotated, it's actually a cylinder with radius 3 over 2 and length 3. No, sorry, not length 3. That's not 2, is it? Q is 2, that's 5 over 2. So length is 2.5. And the volume here is 1/3 pi L R squared. So 1/3 pi times 2.5 times 3 over 2, or 1.5, isn't it? Squared. So that's 15 over 8 pi. Okay, so now all that's left to do is the total volume. Total volume equals 13 over 24 pi plus 15 over 8 pi. 24 is 29 over 12 pi. And there we have it, the last part of the last question. That paper wasn't too bad, some awkward numbers. I actually thought the earlier questions were harder than the later questions in this paper. Let me know what you think in the comments, or if you sat this paper you probably won't be back watching the channel. But if you are and you did sit this paper, let me know what you did on it and what you thought. If you liked this, enjoyed it, found any of it useful, don't forget to like, subscribe, and I'll see you in a future video.